Okay, so hello everybody, good evening, and welcome to the first problem solving session that we are conducting. So, in this problem solving session, we will be covering only problems, no theorems, and the problem level will be from the late AMC level to early AIME level. And actually, AMC and AIME are examinations in the US. So this will be the level of problems, and we'll be taking problems from various topics, not just one topic. Like till now, we have done all our problem solving sessions just based on one topic. Like for example, I have done my problem solving session on number theory, and Nikhil has done his problem solving session in combinatics. Not like that. This time we'll be doing problem solving session on all the topics. So let's start. All the topics in the sense algebra, number theory, combinatorics, and geometry. So let's start. Okay. So here is the first question. So let me dictate the question. Let ABC be a right triangle with right angle C. So ABC is a right triangle where C is the right angle, which means that AB is the hypotenuse. Let D and E be points on segment AB. That line on the top means segment with D between A and E. So it means that D and E are 2 points such that D is between A and E, such that CD and CE. So you have 2 points D and E on AB, and from C you connect the point D from C to D and C to E, and that trisects the 90-degree angle, which means the trisection angles will be 30, 30, 30. Okay, so it trisects angle C, which is a right angle. If the ratio DE over BE is 8 over 15, okay, so they have given us that the ratio DE over BE is equal to 8 over 15. Then tan B, I hope you all know what tan B is. So in any right angle triangle, tan B is the opposite by adjacent. I am talking respective to the angle on the right angle triangle. So the ratio, tan B can be written as m root p by n, where m, p, n are relatively prime positive integers, and p is a positive integer not divisible by the square of any prime number. So you understand what I mean, because if p is divisible by the square of any prime number, that prime number or whatever can be taken out of the square root. But we don't want answers like that. We want answer wherein root p cannot be more rationalized more. So root p is root p. So you cannot make any more simplifications. So that means that is why we are saying p is a positive integer not divisible by the square of any prime. And obviously m and n are relatively prime, because if it is reducible, then we want the whole expression to be irreducible, so it can't be reducible even more. So this is why these conditions have been given. So then tan b is written as m root p over n, and you need to find m plus n plus p. So this is the question, and we'll see who is giving the answer. So you have I think 10 minutes time for solving this, and if you get, and then we'll discuss the answer. If you have got any doubts specifically on the question, then you can ask me now. If you have an answer now, please don't give it right away. You can just type it in the chat, and if you have any questions, you can just ask me now related to the question only. Are there any updates so far? You can just message me. So have you got, I think we can move on to the solution. I think there is some answers. Oh yes, Tanmay, you have from, wait a minute, let me see what you're saying. Oh, but okay. So I think you are on the right track, but yes, continue, continue. So if you have got any, I mean, if you have got any idea on how to start the question, you can tell me, and then we can move on to the full solution. You can just raise your hand if you want to say something and you think that that is the right way to proceed. You can just raise your hand and just tell me, and then we'll see whether it is right or not. Yes, 1 minute. I'll unmute you. 1 minute. Yes, Tanmay, you can speak.
I tried to draw perpendiculars from D and E to BC. Then I used trigonometric ratios of 30° and 60° to find the uh, values. To
Okay, so
find
what is
the
the final answer?
I am not getting the final answer, but after some time, I think I will. I'm
Okay,
trying to 10:30.
yeah, okay. So do you want time or should we move to the answer? I mean the solution. Okay, so how much, like, do you want, how much time do you want, like how much more time do you want, or should I give the answer now? You can just give the feedback so that, I mean, I can know when to start the solution. You can just private chat me. Okay, then I think we will move on to the solution. I think we can move on to the solution. Yeah. So let's move on. Yeah. So now I have drawn this diagram. So first let's visualize the figure. You have this triangle ABC. You can call it ACB also. Whatever you want, you can call it. Okay. So I have drawn the diagram. So you can see this is ACD. ACD equal to DCE is equal to ECB is equal to 30 degrees because it's trisected. Now what I do, if you note properly, I mean if you look at the figure properly, okay, and you consider this triangle CDB, okay, you have this triangle CDB, so you can call this all the three angles A. So you can call ACD equal to A, DCE equal to A, and ECB is also equal to A. A is equal to 30, but just for now I am calling it as A. So you can see that CE is the internal angle bisector of angle DCB. If you note, you can see that angle DCE is the internal angle bisector of angle BCD. So you can see that, right? Because here you have A and here also you have A, so it's bisecting the angle. Okay. So if you are known of this theorem called the angle bisector theorem, if you do not know, I will just a minute. If you do not know, then let me write it down here somewhere. So now you have a triangle. Okay, here is a triangle. Some triangle here. So my diagram isn't that good, but please try to adjust. Let me erase it and let me draw a neat one. So you have here uh, an arbitrary triangle. So this is just any triangle. You have some triangle over here. Okay, wait just a minute. Let me draw it neatly so that you can understand it clearly. Let me go back to the pen and yes. So from here we draw this line. Yes, that's fine. So if there is an angle bisector, okay, so let me call this say A, okay, B, and then you have C, then you have D, then what the angle bisector theorem states is that AB by BD, I mean AD internally bisects angle BAC, okay. So what we do is we say angle, AB by BD. This is the definition of the angle bisector theorem. If you don't know, I would suggest that you note this down in any. So let me just write it down. So in this triangle, if AD is the angle bisector of of angle BAC internally bisects, then you have this AB by BD. AB over BD is going to be equal to AC over CD. This is what the statement of the angle bisector theorem. Okay, so this is what angle bisector theorem says. So this is the theorem we'll be using. If you want to know a proof of this, first I would suggest that you try to prove it using some simple similarity or some this cosine rule. So you can try first. You can try proving this result by using cosine rule or similarity. I would suggest similarity because the easier the approach, it is more fun. So I think it is better that you use similarity, or else you can use cosine rule. It's up to you. So you can try proving this. You can take this as an exercise. So this is what the statement of the angle bisector theorem is. Now we'll be using this theorem on triangle CDB. So if you consider triangle CBD, you can see that CE internally bisects angle BCD. So if this is true, then by the angle bisector theorem, CD over DE should be equal to BC over BE. I think this is clear because of the angle bisector theorem. Now you let CD equal to 2A. You will know why it's 2A and soon you will know. So let CD equals to 2A. Okay. If CD is 2A, then by the angle bisector theorem, CD by DE is equal to CB by B. Let me write that down. It's already here. So CD by DE equals BC by BE. Then you can rearrange it as CD by so you can rearrange it like this. CD by DE is equal to CB by B. So then you can just substitute the values. Like we know DE by B is 8 over 15, right? So when you substitute the values, you get this 2A over 8 is equal to CB by 15. Okay, so by the angle bisector theorem, you can get this. You have D over B as 15, 8 over 15. So you do some small algebraic manipulation using this angle bisector theorem and you get this 2A over 8 equal to CB over 15. You can try that out. I'll leave that to you. Okay, so then this means that again when you solve it, you get CB in terms of A. So that is CB is 15A over 4. Okay, now you have got CB in terms of A, CD in terms of A. We have CB and CD both in terms of A. Now what I am doing, I am dropping a perpendicular from D to BC. Not from me, only from D. Tanmay has said we drop perpendiculars from D and D to BC. But this time I am only dropping perpendicular from D to BC. So let that intersect at some point F. Say I am just taking point F over here. Then note that this triangle CDF is a 30, 60, 90 triangle. Why? Why is that so? Because if you note these two angles, just a minute, let me just draw it. These two angles are 30 and 30 respectively. So 30 plus 30 is 60 and this is 60. This is 90 degrees. So this has to be 30, right? Because by symmetry this has to be 30. So you have a 30, 60, 90 a right angle triangle. So now if you note that the ratio of the sides of a 30, 60, 90 triangle will be, so if it's 30, 60, 90, if this angle is 30, this is 60 and this is 90, it will be 1 is to root 3 is to 2. So this side, this will be, I'm just writing down the ratios. 1 is to root 3 is to 2. So you have 1 is to root 3 is to 2. So that's the ratio. Now, what do we know? What is CA here? I mean CD here. CD is nothing but 2A, right? So this must be root 3 into A and this must be equal to A. So now you have this is root 3A and this is equal to A. Now this is A. You have this length is A. Okay, this length is A root 3 and this length is 2A. Okay, I'm just writing down the lengths. So now you have this. Then what will F be here? See, you know CD. What is CD? CD is 15A over 4. And we also know CF, that is nothing but A. Then what is VFB? It will clearly be what? It will be 15A by 4 minus A. That is nothing but 11A by 4. That's what is written over here. 11A by 4. And this is what CF and FD. So here you have 11A over 4. Okay, you have here 11A over 4. And you have here A root 3. Now, what do you think will come in mind now? This angle, this is a 90, this is a 90 degree angle. Now you have here, you have the length of DF and you have the length of FB. Now what is the question? You want to find tan of this angle. So immediately what comes in mind? The tangent ratio in the right angle triangle. So then you see that this is the, if you take it, this is the angle which we want. Opposite is this and adjacent is this. So what is tan B? It will be FD by FB, which is nothing but A root 3 by 11A by 4. So A root 3 over 11A by 4. I mean, you can just write it down. You can see this one over here. Okay. You can just cancel the A's out and then you can take the 4 on the top. You will get it as 4 root 3 over 11. So we wanted our answer in the form M root P over N, if I'm not wrong, where P is not divisible by the square of any prime. 3 is not divisible by the square of any prime. And M and N are relatively prime. You can see 4 and 11 have GCD as 1. So we can say M equal to 4, M equal to 4, P equal to 3 and N is 11. So M plus P plus N is going to be equal to 4 plus 3 plus 11, which is 18. Okay, so this is the answer for the first question. If you have any doubts in this, you can raise your hand and I'll clear it. And also I think some of you have not some of you have not, you have joined late, right? So you might not know the question. So for them you can just refer this question out here. You can just read it and then you can try solving it on your own, because anyway I will go back to the solution slide so you can refer the solution. So, are there any doubts in the solution for the people who have who have seen the problem and the solution? If there are any doubts, then you can just raise your hand and I think I'll clear it. Okay, great, no doubts. I hope all of you have taken down the question and I think you can try solving it. So, here is the solution. You can just have a glimpse of the solution. Here's the diagram and here are the things. So, I think you've got a glimpse. Now, I think we can move on. I hope. Okay, so now here is the second question of the day. Okay, I think the question is not quite visible, but I'll read it out because some font problem or something. It may be because this question we have taken an image, so it might be a problem. Okay, so the second question states that at a certain university, there is a university. Maybe you can name whatever university you want, IIT, MIT, or whatever. The division of mathematical sciences. Okay, I mean mathematics is just not a pure mathematics or something. There are, I mean, many different categories in mathematics. So in mathematical sciences, okay, there are three, I mean, there are three departments: mathematics, statistics, and computer science. So there are three departments, and in each department there are two male and female professors, which means that there are two men and two women who are professors in the department. Okay, a committee of 6 professors is to contain 3 men and 3 women. So what they are telling, of these 12 people, okay, because four you have four in each department, of these 12 people you want to select 6 people. Okay, instead of professors I'm putting people, so you want to select 6 people or professors, and in that 6 professors you need to have 3 men and 3 women, exactly 3 men, exactly 3 women. And also there must be at least, I mean, there must also contain exactly 2 professors from each of the 3 departments. So I hope you understand the question. So let me read the last part. A committee of 6, so you need to select 6 people who contain 3 men and 3 women, and must also contain 2 professors from each of the 3 departments. So there are 3 men, 3 women, and from each department you need to have at least, I mean, you need to have exactly 2 people. Okay, so I mean, this is the thing that they have stated. Okay, and because now why they have given this 2 over here is because there are 4 people in each department. So it can be like this also. One department they can select 1 person, second department they can select 2 persons, and the third department they can select 3 people. But that is not counted. In each department 2 should be there. That is why they have given this. It is a, I mean, it is a constraint that they have given. So the question is, find the number of possible committees that can be formed subject to these requirements. And note that all of them are not identical, because people cannot be identical. So all of them are distinct. And even the departments are distinct, because there are 3 distinct departments. So mathematics, statistics, and computer science are 3 different departments. So yeah, so you can try solving this problem. It's actually I mean, a kind of elementary counting problem. So you can try solving this question, and if you have any answer, you can just raise your hand and you can give your answer. And particularly, are there any doubts in this question? If you have doubts, then you can just raise your hands. Has anybody got the answer? You can just update. So should we move on to the solution? You can just message in private chat this by saying yes or no. Yeah, that's not a problem, Tanmay, and I think yeah, most of you are saying me to move on to the solution. So, so if you note the solution, so there are only two possible cases. First case is one man and one woman is being chosen from each department. This is yes, Tanmay, your answer is right. Okay, in the first case, one man and one woman is chosen from each department. Second case is that two men are chosen from one department, two women are chosen from another department, one man and one woman are chosen from the remaining third department. Okay, yes, so somebody is annotating, please don't annotate. Okay, I have disabled annotation. Okay, so in the first case, there are 2 choose 1 times 2 choose 1 equal to 4 ways to choose one man and one woman. I think it's clear because each department there are how many people? How many? I mean, each in each department on each gender there are two people, and from each gender you are choosing one person. So that will be 2 choose 1 times 2 choose 1 equal to 4 ways, because from two departments we are choosing the two people. I mean, the two people from two genders we are choosing one. So there are 4 ways to choose one man and one woman. Okay, but there are 4 cube total ways because there are 3 departments. There are 3 departments, so there will be 4 cube total ways, which is 64 for case 1. Now the second case is there is only one way to choose two professors of the same gender, because see, there are only two people available. From that you want to choose two. Okay, I mean in each gender I'm speaking in the aspect of gender. So there are two possibilities. From the two people, two again you are choosing, so there's nothing but two choose two, which is one. So there is only one possible way to choose two professors of the same gender from a department. And again there are 4 ways to choose one man and one woman, so it can be 4 ways from the remaining department, so the final department. So there is 1 times 4, so there are totally 4 ways to choose 2 men from one department, 2 women from another department, and 1 man and 1 woman from the third department. So this is called this why we are multiplying this, due to multiplication principle. I think Nikhil has taken this. But however, if you note, there are 3 factorial equal to 6 different department orders, because last time they were identical. So that's why we did 4 cube, because repetitions can be done over here. But here, since repetitions cannot be done, it will be 3 factorial. So there are 6 different department orders. So you can have in say department A, B, and C. In A department you choose 2 men, B department you choose 2 women, and C department you choose 1 man and 1 woman. So like that there are 6 different possibilities. So again, by multiplication principle, the number of possibilities for case 2 will be 4 times 6, which is 24. So in total you have 64 plus 24 equal to 88 possibilities. So this is the solution for the second question, and if you have any doubts you can just ask. Any questions you can just private chat. If you have no questions you can just say no. Okay, I don't think there are any questions, so I think we can move on to the next question. Okay, so this is a very interesting question. The question states that there is a prime number p for which 16p plus 1 is the cube of a positive integer. Find p. So the question states that there is a prime number p, some arbitrary prime number, I mean that satisfies that 16p plus 1 should be the cube of a positive integer. So you need to find that prime p. I think you have understood the question. It's just a one-liner. It's just a one-line question. And I think the font is too big and the space between the letters is too small compared to the size of the font. So it might not be quite visible. So I have dictated it that there is a prime p such that 16p plus 1 is a cube of a positive integer, and you need to find p. So you can just, and so for example, now let me give a hint. So you can say 16p plus 1 equal to x cube. You want to find p. So if you find x, then you can find p. So whatever you may, so then you get 16p equal to x cube minus 1, and then you do some factorization. Then you try to apply some other things, and then you try to come to a conclusion, and then you get the answer. So this is the approach. So you can try in this approach. If you have another approach, you can go with that as well. It's up to you. This is quite an easy question, so I think I'll give a little bit, I mean, quite less time I'll give so that we can move on and complete the class. Okay, Ravi, your answer is correct, but can you explain how you have got the answer?
Yeah, yeah, yeah.
Yes, you can explain how you have got the answer.
Yeah, 16p plus 1 is equal to x cube, I took it as.
Yes.
So it's odd.
Which one is odd?
So the cube is odd, x cube.
Yes,
So
correct.
16. So x cube minus 1 will be 16p.
X cube minus 1. Yes, right, correct.
So x minus 1 of x square plus x plus 1 will be 16p.
Yeah, right, right.
X is odd, so x minus 1 should be even.
Yeah, yeah.
So even x square plus x plus 1 will also be odd.
Yeah, correct.
So x minus 1 should be a multiple of 16 and x square plus x plus 1 is equal to p.
Yes, correct.
X will be 17.
Yes, yes, correct. Right, right.
So p will be 17 square plus 17.
Yeah, yeah, yeah. Correct, correct. Answer is right. So P is 17 square plus 17 plus 1, which is nothing but 17 square is plus 17 is nothing but 289 plus 17 plus 1. 289 plus 17 is nothing but 306, and if you add up a plus 1, you get 307. And it's simple to verify that 307 is going to be a prime number. Yes, 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 correct answer. Yeah. Okay. Two other people, Kushi and Tanmay, have also gotten the correct answer. Very good. I think this problem was quite a simple question. Okay, so let's move on to the solution. So this here is a solution. I mean, it's the same solution as what Ravi had told. So the thing is that we put a cubed equal to 16p plus 1, and clearly a must be odd. The cube is odd, right? So we get, you know, this, I hope all of you know this factorization. I think we have done this in one of our classes in algebra class taken by Chinmay. And this factorization is nothing but a cube minus b cube is equal to a minus b times a square plus ab plus b square. You can do, or you can even do synthetic in division, and you can get this. So now if you see here, a cube minus 1 equal to 16p, which means that a minus 1 times a square plus a plus 1 is 16p. Now since a is odd, a minus 1 has to be even. Agreed. Now since a is odd, odd square is odd, and odd plus odd is even, and even plus 1 is odd. So it will be an odd number. So this means that a minus 16, a minus 1 must be a multiple of 16. Okay, and a square plus a plus 1 is odd, so there is no other option other than p. So a square plus a plus 1 is p. So this forces that a minus 1 is 16. I hope you understand what I am trying to say. Okay, so a minus 1 should be 16, which forces that a equal to 17. Now a square plus a plus 1 is nothing but 17 square plus 17 plus 1, which is going to be equal to, you can just check it here, it will be 289 plus 17 plus 1, which is nothing but 307. Okay, if you have any doubts, you can ask. Or if there are no doubts, you can just quickly put no doubts so that we can not waste time and we can move on to the next problem. Great, there are no doubts, so I think we can move on. Okay, so here is a fourth question. It's a very interesting question. Two sides of a triangle are 10 and 5 centimeter in length, and the length of the median to the third side is 6.5 centimeter. So what they are saying, let me just draw the diagram here. It will take a minute or two. Just a minute. Let me go back here. So you have a triangle over here. Just a minute. This is just too bad. Okay, so you have a triangle. Just a minute. So you have a triangle like this. Okay, and you are drawing the median. So this side is 5 centimeter. This is 10, and the median is 6.5. The question is, what is the question is that the area of this triangle is 6 root p. It can be expressed as 6 root p centimeter square, again where p is not divisible by the square of any prime number, or not necessary. They have not stated anything like that over here. So 6 root p. So even if even p can be I mean a perfect square, but they have just said 6 root p. If they have given anything like whatever that like no in the first question that p is not divisible by the square of any prime, then it's all right. So I don't want to make any new definitions. So you can just assume p to be anything, any positive integer. So area of the triangle is 6 root p centimeter square, and the question is to find p. This question is quite an interesting one, so you can and try solving it. Got an answer? You can just message me. Yes, then may whatever you are telling is right, but I just want, I mean, you can just send me the final answer. What answer you have got? Are there any answers so far? Or should I move on to the solution now? Because I think this is quite an interesting one, but it's quite a easy question as well. If you know a well-known theorem called, I mean, I won't give the name of the theorem, but if you know a well-known theorem, most of you might be knowing it because I think Kumaraswamy sir has taken the class in geometry. If you have solved it, then you can send me the answer, or else you can wait till we give you the solution. Yes, your answer is correct. Yeah, correct one. Yes, right, right. You're right. So Khushi has given the correct answer. I think we can move on to the solution now because one of them has given the correct answer. So the key idea that we are using is Apollonius theorem and Heron's formula. So what Apollonius theorem states? It states that, so if you have a triangle, just a minute, let me draw the figure so that it can be clear. If you have any triangle like this, any triangle like this over here, okay, let me just draw like this now. Okay, this is A. This, just a minute, just a minute. Yeah. So yeah, so you have a triangle here A, B, C, and yeah, so you have a triangle over here A, B, C, and you have, this is the midpoint of BC. Just you can call it D. Okay. Then Apollonius theorem states that AB square plus AC square equals to 2 times BD, which is nothing but half BC, 2 times BD square plus AD square. So from here it is very easy to proceed to the answer. Because you have something, you have AD in terms of, I mean, you have BC here. We want to know BC right now because we are given this is as 5, this is as 10, and this is 6.5. So luckily we have now BC in terms of AB, AD, and AC. So I think it will be easy to get the value of BC. So what happens? You get like this an expression 4AD square equals 2AB square plus 2AC square minus BC square. So now you have an expression in terms of BC, I mean BC for BC in terms of AB, AC and AD. That is BC square is 2AB square plus 2AC square minus 4AD square. Now inputting the values of AB, AC and AD, which is 10, 5 and 6.5 respectively. Here they have put it as 13/2. So when you substitute the values, you get, I mean, after upon simplification, you get 81. So now you have BC squared is equal to 81, giving that BC is equal to 9. Now you have the sides of the triangle. Here is 10, here is 5, and here is 9. Right? BC is 9. So what we can do now? We can apply Heron's formula. What is Heron's formula states? In a triangle ABC with sides A, B and C, okay? In any triangle with sides A, B and C, area of ABC is root of S times S minus A times S minus B and times S minus C. Under root, full under root. S minus C. So this is what Heron's formula states, and S is the semi-perimeter. What is the semi-perimeter? A plus B plus C by 2. So we can use Heron's formula over here. So here you have S is equal to 9 plus 10 plus 5 over 2, which is 12. And you know A, B and C values, that is, you can just input the values and then you get root over 12 times 3 times 7 times 2. So you will get like 12 minus 9, then 12 minus 5 and 12 minus 10. And that's going to be 12 times 3 times 7 times 2, and you have square root. So that will be equal to 6 root P. Now, this product, inner product will be 504. Root over 504. Now, 504 is 36 into 14. So you can take that 6 out, because 36 equal to 6 square. You can take 6 out of the root and you get 6 root 14. Now what is 6 root 14? That is equal to 6 root P. And we are asked to find P. So what will be P? P will be equal to 14. So this is the solution for the fourth problem. And I think the class ends here because it's already 5. So thank you very much for attending this problem solving session. I think you had fun solving the problems, and I would like to say that for a while now we'll be having all the sessions will be problem solving. A few of the sessions will be on topics. Rarely we'll be keeping topics on theory, because problem solving is more important than theory. But we'll be giving theory, like, so that you know the concepts before the problem solving. That is also equivalently important, but we'll be focusing more on problem solving. And I hope you have enjoyed the class. Thanks once again for attending this session. And I think we can stop here. It's a good place to stop.